right. Our dear viewers, I take this opportunity to welcome you to this very first lesson of effect of electricity on substances. And under this topic, we shall basically discuss what electrolysis is. I'm going to be taking you through O-level chemistry, and I feel comfortable when I first introduce myself. My name is Chiwafu Matthias. I happen to be a teacher of chemistry. All right. Before we go on, I want you to even inform your friends that there is this YouTube channel called Hyper and Chiwafu Academic Channel. Tell your friends to subscribe. Let them come and watch whatever we discuss here. All right. Now let's go. All right. So we are going to be talking chemistry, and the topic is electrolysis. This is our lesson 1. We are going to have various lessons of this topic, and then I believe at the end of all those lessons, you will be knowing what electrolysis is. Dear viewers, this word electrolysis, this word electrolysis comes from 2 words, okay? Yes, we can split it into 2 words. There is electro and then lysis. So what does that mean? It means that we have got that word lysis, and then we also have this word electro. Electro is directly connected to electricity. Electro is directly connected to electricity, or what you can call electric current. Yes. And then lysis, the word lysis means to break down. It means to break what? It means to break down. So what does that mean? It clearly means that in this topic, we are going to be talking about compounds. Let me hope you know what they call a compound. From your senior on chemistry, you must have learned about the definition of a compound. And then a compound is defined as, first remember, what is a compound? Alright, a compound is a substance that consists of 2 or more elements chemically combined together. So we are going to be talking about compounds, okay? And then we are going to be looking at, basically, mostly they are going to be ionic compounds, okay? Yes, we are going to be looking at how these ionic compounds are broken down using electricity or electric current. So dear viewers, I'm telling you that in electrolysis, we are going to be looking at the breakdown, the decomposition of basically ionic compounds. However, we shall see that there are a few other compounds which are not ionic, but they can also be decomposed using electricity. So for now, what you must be hoping to study in this topic is the breakdown of ionic compounds, which we shall see that these ionic compounds must be in their solution form, or the aqueous state, or molten state. That is, when you heat this ionic compound up to its melting point. So you very well know from the topic of atomic structure, chemical bonding, and the periodic table that ionic compounds are usually solids at room temperature. So then, when they dissolve in water, they form aqueous solutions, and when they are heated, they form molten compounds. So we shall be understanding all that. But for now, what you must have in your mind is that with the electrolysis, we are going to be discussing the decomposition, the breakdown of compounds, okay, using electricity. All right. Now, dear viewers, we are saying that the topic is effect of electricity on substances. And when it comes to how substances behave with electricity, there are those substances that allow electricity to pass through them. And there are those substances which can never allow electricity to pass through them. All right. So now, if I may ask, How do we call the solid substances that allow electricity to pass through them? How do we call those substances? The solid substances that allow electricity to pass through them. How do we call them? Alright, one person has already said they are called conductors. Okay? Yes, so under the effect of electricity on substances, we have to first of all know that there are two categories of substances when it comes to their behavior with the electricity. And I want you to know that solid substances that allow electricity, solid substances that allow electricity to pass through them, solid substances that allow electricity to pass through them are called conductors. Perfect, they are called conductors. Already you are learning. So if you are one of those people who didn't know that conductors are the solid substances that allow electricity to pass through them, okay, right now you know. So solid substances that allow electricity to pass through them are called conductors. We are going to be talking about electrolytes. Electrolytes also allow electricity to pass through them. They also conduct electricity. But for them, they conduct electricity when they are either in the molten state or the aqueous state, or when they have dissolved in water to form the aqueous solutions. Right now, we are talking about solid substances. All right. So, can we have examples of conductors? Examples of conductors. Right. Examples of conductors. Can you think about some of these examples of conductors? Yes, we are talking about solid substances that can allow electricity to pass through them. So we have called those solid substances conductors. Do you know some examples of conductors? Yes. Alright. Number one, we have metals. Alright. Metals. All metals are conductors. And we are going to explain why metals are conductors. And then number two, we have carbon. Carbon is a non-metal, so we expect it not to conduct electricity, because when we are learning about the differences between metals and non-metals, you learned that metals conduct electricity and then non-metals do not conduct what? Do not conduct electricity. But we are saying that carbon in the form of graphite, conducts electricity. Therefore, it is a conductor. And then in this topic, we shall see that the electrodes, we shall discuss what electrodes are. Yes, in those lessons to come, we shall be talking about what electrodes are. Okay? Yes, we shall clearly see that these electrodes also conduct electricity. Is that okay? And we shall get to know that most of the electrodes are either metals or carbon in the form of graphite. All right. Now, we need to answer this question. What is the question? What enables metals to conduct? What enables metals to conduct electricity? What enables metals to conduct electricity? Or we can phrase this question by saying that what are the conducting particles? What are the conducting particles in metals? What are the conducting particles in what? In metals. So we need to first know this. what enables these metals to conduct electricity? Because by the time we say that metals are conductors, metals can conduct electricity, it simply means that they have got those particles, metals have got those particles that enable them to conduct electricity. And that's the question I want us to answer, okay? Yes. What enables metals to conduct electricity? Why are metals called conductors? What are the conducting particles in the metals, okay? In metals. A question mark, okay? As in, what enables the metals to conduct electricity? All right, can you think of that? Yes, okay. What enables these metals to conduct electricity? All right. Now, the answer is, metals have delocalized, electrons, which are mobile, All right, so I want you to know that the delocalized electrons are the conducting particles in the metals. Look, if any substance is to conduct electricity, it must have the particles that enables it to conduct electricity. And we are saying that for the metals, they are the delocalized electrons. Now, we have to understand, how do these delocalized electrons come about? Because metals have electrons, and then non-metals also have what? And non-metals also have electrons. Now, why are we saying that the metals have the delocalized electrons, and it is these delocalized electrons that enable them to conduct electricity? Now, this question can be answered by using what we call metallic bonding. Do you remember what metallic bonding is? All right, what is metallic bonding? All right, what is the metallic bonding? Okay, we need to understand what metallic bonding is. And when we understand what... Now, dear viewers, we are going to discuss metallic bonding. So, that has been our lesson 1, okay? The next lesson, we are starting with metallic bonding to help us understand why metals are conductors. Thank you for viewing. Alright, dear viewers, I want to welcome you to our lesson 2. The topic is effect of electricity on substances. So this is our lesson 2. Alright, in lesson 1 we introduced ourselves to this topic, and then we also said that solid substances that allow electricity to pass through them are called conductors, you understand? And then we clearly say that if electricity can pass through these conductors, there must be particles that enable these conductors for electricity to pass through them. Alright, and I had clearly told you that the conductors have got their conducting particles known as the delocalized electrons. So whenever a question comes and they ask you, name the conducting particles in maybe copper, maybe zinc, maybe what, provided it is a metal, the conducting particles are delocalized electrons. And then these delocalized electrons, they must be mobile, they must be moving, you understand? Yes. So one thing you have to know is that whenever we say that a substance conducts electricity, it has got the particles that enables it to conduct what? To conduct electricity, you understand? And then these particles must be moving, they must be mobile, alright? Dear wonderful children of God, we are saying that the conducting particles in metals are the delocalized electrons. How do they come about? Look here. Now, metallic bonding is entirely for metal atoms. And one thing you have to know is that these metal atoms must be of the same kind. These metal atoms must be of the same what? Must be of the same kind. You understand? Yes. So, metallic bonding is going to help us understand how these localized electrons come about. So metallic bonding, first of all, is the type of bonding, between metal atoms, of the same kind, This point of the same kind is very, very, very important. You understand? And listen to this. If we've got a metal, let's say magnesium, you understand? This magnesium, it's a metal. It is an element, because elements are of two types. They are metals and non-metals. You understand? Yes. So we are saying that, by the way, from your topic of atomic structure, chemical bonding, and the periodic table, you learned about writing the electronic configurations. And from those electronic configurations, you can tell which one is a metal and which one is a non-metal. All right. For example, I'm saying that magnesium, the chemical symbol is Mg, capital M, then small g, alright? So magnesium is a metal, and you know its atomic number, isn't it? The atomic number of magnesium is 12. So if the atomic number of magnesium is 12, you must remember what atomic number is. What is atomic number? I understand that that is one of the topics you love most, atomic structure. Alright, atomic number is defined as the number of protons in the nucleus of an atom. You understand? Yes, and we are saying that in an atom, the number of protons must be equal to the number of electrons. An atom qualifies to be called an atom if the number of protons is equal to the number of electrons. Yes, that's where we are going. Now, I'm saying that if we have magnesium, it's a metal. It is an element. You understand? Yes. Now, this magnesium element, by the time we call it an element, it means that very many atoms have combined together to form that magnesium element. This is one thing you must learn from teacher Matthias, that it is the atoms that combine together. The metal atoms bond together. Bonding is just combining, okay? So the metal atoms combine together to form the metal element. So if we are talking about magnesium element, it simply means that the magnesium atoms combine together to form the magnesium element. Now, the question which we are trying to answer is, how do these magnesium atoms combine? Okay? Yes, how do they combine? How do they bond? Okay? When we talk of metal atoms combining or magnesium atoms combining, that's bonding. Bonding means come together. Let's be together. Let us develop that bond. You understand? And you also have a bond with your mother, you have a bond with your father, and your friends. I also have a bond with my friend. Hey, it's not only you who has friends, I also have. Alright? So now, magnesium, it has atomic number 12. Okay? Yes. So that means that the number of protons in the nucleus, because you must know that the protons and the neutrons are found in the nucleus of an atom. Yes, the protons and the neutrons are found in the nucleus. So now, number of protons in the nucleus of the magnesium atom is 12. Yes, because the atomic number is 12, and atomic number is defined as the number of protons in the nucleus of an atom. But now I'm saying that in an atom, the number of protons is equal to the number of electrons. The moment those two are not equal, then we come up with what we call ions. Cations, positive ions, anions, negative ions. But the moment the number of protons is equal to the number of electrons, then we have what we call an atom, okay? So if the magnesium atom has 12 protons, then how many